Hi, this is Cindy Schwartz again from Vassar College. Today we're going to work on a problem in kinematics in a one-dimensional case. One-dimensional problems can either be in the x direction or the y direction, and the one that we're going to do is going to be in the y direction. So y is going to be our variable. Okay, a typical problem involving y is usually called a free fall problem. So we're going to take the case where we have a building, and the building is 150 meters high, and someone is going to throw a ball upward with a velocity of 30 meters per second. What we'd like to do is find the time it takes the ball to hit the ground. Okay, so I'm going to use some equations, and every book uses different notation, so you may find that my equations are a little bit different than the ones that are in your own textbook, but hopefully it shouldn't be too hard to figure things out. So the way I usually start a problem is by drawing a picture and indicating what I know and what I don't know. So I'm going to call the starting position, remember the ball is being thrown upward, I'm going to call the starting position 150 meters. By doing that, the final position is 0 meters. You notice I've made a choice, and my choice is that the positive direction is measured upward. So what do we know? We know that the initial speed is positive 30 meters per second, and we want to find the time. So one equation that we could use looks something like this. Y final equals y0 plus v0t plus 1/2 at squared. If I put my numbers in there, the final y is 0, notice, because that's where we end up back at the ground. And the initial y is 150 meters plus 30t plus 1/2. And in this case, because positive is upward, the acceleration due to gravity is negative. And that is the equation that we have to solve. Now, this is a quadratic equation, and so usually you try to rewrite it in a format that is a little bit more familiar. So I rewrote this as 4.9 t squared minus 30t minus 150 is equal to 0. Once we have that equation, we can use the quadratic formula. T equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And of course, we have to remember what a, b, and c are. A is the coefficient in front of the t squared term, which is 4.9. B is the coefficient in front of the t term, which is negative 30. And c is the coefficient that doesn't have any t at all, minus 150. Now, when I plug these numbers into my calculator, I get two different solutions for t. So I'm going to do this now on the next slide. So here's what we get. We get t is equal to 30 plus or minus 62 over 9.8. Now you notice one of those is going to give us a positive answer, and one of those is going to give us a negative answer. We're concerned at this point with the positive answer, which is going to be 30 plus 62 over 9.8, which is equal to 9.4 seconds. You may want to think about what the negative t is? Well, that would be the time that the ball would have been at had it started back at the ground before it even came up to the person again. So this is a mathematical solution, but it's not a physical solution. Okay, so hopefully that was a good review of the quadratic formula. For this type of problem, however, there are some ways that you can solve it and avoid using the quadratic formula completely. So I'm going to show you another way using different equations. There's one that looks like this. And we can use that to find V0, to find V final. I notice it's 0 minus 150. And we get V final is equal to plus or minus 62 meters per second. And here's where the physics knowledge has to come in. The velocity at that point is pointing downward, so the physical solution is negative 62. Now we can use that in our other equation to solve for t. So again, remember it's negative 62 equals positive 30 minus 9.8 times t, and no surprise we get t is equal to 9.4 seconds. So again, this was a review of the quadratic formula, but you should also know that if you like to avoid using the quadratic formula, there are other ways to solve the problem.